The Texas Air Quality Study in 2000 found that HRVOCs, or highly reactive volatile organic compounds, were the cause of high ozone levels in Houston. The HRVOCs, which include light alkenes, propene, ethane, 1,3-butadiene, and forms of butene, combine with coastal winds to form ozone. Because of the air quality study, a plan was created that required all chemical plants to have systems in place to monitor emissions by January of 2006. Let's take a look at how these monitoring systems work. The general way of monitoring emissions is through gas chromatography, but how does it work? The most common type of gas chromatography is gas chromatography with mass spectrometry. In a gas chromatographer, the chemicals are separated based on how quickly they travel, with the more volatile chemicals traveling more quickly. The outside of the chromatograph is heated to move the chemicals through the system more quickly. However, even though heat speeds up the process, it can also lower the quality of the chemical separation. Once the chemicals are separated, the mass spectrometer component of the gas chromatograph is used to determine the structure of the chemical compounds so that they can be identified. The mass spectrometer blasts the molecules with electrons so that they become positively charged ions. These ions pass through the filter and then their mass and structure can be determined. This allows the chemical plant to look at the amount of HRVOCs emitted over time. Environ, a group solicited by the Houston Advanced Research Center, or HARC, went in May of 2006 to check on the monitoring systems. It was found that the most commonly used system in Texas petrochemical plants is the Siemens Maxim II process gas chromatograph. This system uses two specific methods of gas chromatography which work well in specifically identifying HRVOCs. First, it uses a flame ionization detector, or an FID. The FID is the most sensitive type of detector for organic molecules, which is what makes it ideal for identifying HRVOCs. The gas sample is burnt, and ions are created through the combustion of the gas. This creates a current that can be measured to identify the sample. The combustion breaks up molecules into fragments with carbon atoms. More carbon atoms mean more fragments and more sensitivity toward identifying the compound. And this is why organic molecules, such as HRVOCs, are so well detected. The second method used by the Siemens Maxim II process gas chromatograph is electron capture detection. The electron capture detector is sensitive to highly electronegative elements such as halogens, making it a good detector for HRVOCs. There are two electrodes that emit radiation, usually in the form of nitrogen or hydrogen. Electrons collide with the gas and create ions. The highly electronegative atoms are captured and identified. Environ found that when looking at all 9 chemical plants, these monitors reduced emissions by about 17% of the overall allowed amount. So, these monitors were working, to an extent. However, only time would tell how effective these monitors could really become.